Astronauts recently discovered something amazing and surprising using the James Webb Space Telescope. They have identified the most distant planetary clusters ever discovered in the universe. These globular clusters are large groups of stars, containing millions of individual stars. What makes this discovery so exciting is that these clusters are the remnants of the first stars to appear in the universe, providing a window into the early stages of the universe's evolution. The discovery opens new doors to our understanding of the universe and raises questions about how the discovery can reshape everything we thought about the creation and the evolution of galaxies. With the James Webb Space Telescope continuing to make historic discoveries, we are on the verge of revolutionary observations. If you are curious about the world and its endless secrets, keep updated by subscribing to our channel, like this video, and turn the notification bell. This is an exciting time for space exploration in the universe, and you don't want to miss it. The first science-quality image taken by NASA's newest space telescope, the James Webb Space Telescope, has provided a stunning view of a distant galaxy surrounded by dense star clusters. These star clusters are important because they may contain some of the first stars to appear in the universe. 9 billion light-years from Earth, a team of Canadian astronomers has observed what are called sparkler or spark galaxies because of their unique elongated structure and dense bodies surrounding them. These round things look like tiny, reddish-yellow bubbles that sparkled like sparks. While the galaxy's long form is impressive, it's the surrounding star clusters that have attracted the attention of scientists. These dense objects may represent some of the most distant planetary clusters ever discovered, as the discovery is indicative of a planet. But what exactly is a bullet pile and why is it important? Globular clusters are collections of ancient stars from the time when the galaxy they inhabit was formed and are important because they contain cosmic regions and important information about the beginning of their formation and evolution. By studying these clusters, astronomers can unlock information about the history of galaxies and the universe itself. A group of Canadian scientists focused their research on dense objects around the Sparkler galaxy and found 5 of these objects to be globular clusters. What is more important than this discovery is that these clusters are the oldest ever discovered, dating back to the beginnings of the universe. According to co-author Karthik G. Iyer, the discovery of such a rare and unique object early in the data collected by the James Webb Space Telescope is surprising. The flares seen around the main body of the Sparkler galaxy are massive and ancient, representing some of the oldest star systems ever discovered. This discovery has profound implications and offers the potential to provide fundamental insights into the evolution of the universe, the formation of galaxies, and the birth of stars. Karthik Iyer also explained that with data from the James Webb Space Telescope, the team was able to study the light flashes emitted by these clusters at different wavelengths. This enabled them to build accurate models of the globular clusters and learn more about their physical properties, including their age and the number of stars they contain. This type of detailed analysis was simply not possible before the deployment of the James Webb Space Telescope. Previously, astronomers couldn't accurately determine the age of the first stars in distant galaxies using globular clusters. The capabilities of this new space telescope have drastically changed that, making it possible to study these ancient clusters in unprecedented detail. In a separate interview, study co-author Lamola, an astronomer from the University of Toronto, highlighted the overarching goal of this research: to date all objects in the universe, including stars, galaxies, and globular clusters, to better understand the timeline of star formation across the cosmos. One of the mysteries of astrophysics is the age of planetary clusters. Even in our own Milky Way, there are about 150 planetary clusters, whose age is unknown. But the discovery of ancient and distant world clusters may hold the key to solving this mystery. Understanding when and how these clusters formed can provide important clues about the early universe and its rapid expansion, and help solve some of the biggest questions of modern astronomy. One of the challenges astronomers face when studying globular clusters is determining their age. Old world clusters, such as the Milky Way galaxy, are extremely complex because of their great age and the changes they have undergone over billions of years. The Sparkler galaxy, on the other hand, was discovered about 9 billion years ago, giving astronomers a clearer view of cosmic clusters at a very early age. This makes it easier to calculate their age, as it is easier to determine the age of a child compared to an adult. According to Lamola, Estimating the age of a 1-year-old child is easier than estimating the age of a 50 or 55-year-old. Here is an edited version of the article with improved grammar, clarity, and structure. The same logic applies to studying galaxies and globular clusters at different points in their life cycles. To further confirm the age of the globular clusters in the Sparkler galaxy, astronomers use data from the James Webb Space Telescope's NIRISS instrument. The instrument allows them to detect the absence of oxygen, a common element in young star clusters that are forming new stars. The lack of oxygen means that these clusters are old and no longer producing new stars. In addition, the James Webb Space Telescope is supported by the Hubble Space Telescope with a feature called dynamic checking. This effect, predicted by Einstein's general theory of relativity, occurs when massive objects bend spacetime and collide with the path of light. This makes it possible to magnify distant objects, which can be seen by astronomers. Gravitational focusing occurs when massive objects such as galaxy clusters act as celestial lenses, bending and amplifying light from background objects. In the case of the Sparkler galaxy, crystallization from the galaxy cluster MAX 0723 distorted its shape and magnified it so that the James Webb Space Telescope could see it. Amazingly, clusters appear nearby at certain points in the image due to this repulsion effect, confirming that they are still orbiting the Sparkler galaxy. However, astronomers still do not know exactly how much the MAX 0723 cluster adds to the galaxy's appearance. To get a more accurate estimate of magnification, the team plans to create a more accurate model of the focal effect. Once they have a better understanding of this magnification, they will be able to obtain more information about the age and distance of the star clusters in the Sparkler galaxy. Because of the importance of this discovery, the research team will continue to use the James Webb Space Telescope to observe 5 large galaxy clusters. They hope to find other systems similar to the Sparkler galaxy and to better understand the formation and evolution of globular clusters. The James Webb Space Telescope's unique ability to observe objects at great distances has already proven to be a game-changer in the study of distant globular clusters, and astronomers anticipate that this will lead to even more groundbreaking research in the future. By studying these ancient stellar systems, scientists hope to answer fundamental questions about how galaxies and stars have evolved over billions of years. There are 2 competing theories about how globular clusters formed. One suggests that they formed during the cosmic dawn, the early stage of star and galaxy formation, while the other theory posits that they formed during the cosmic midday, when star and galaxy formation was at its peak. This discovery has not only deepened our understanding of globular clusters and galaxy formation, but has also had a significant impact on our overall comprehension of the universe. These discoveries prompted NASA to think about developing more powerful telescopes to continue exploring the mysteries of the universe. The James Webb Space Telescope has released data from a radio and near-infrared camera showing that 4 of the 6 main galaxies detected are strongly redshifted. This suggests that the telescope could see these galaxies 300 to 500 million years after the Big Bang. These galaxies don't contain anything as heavy as carbon, which is amazing considering the universe is 13.8 billion years old. The discovery of these galaxies challenges our understanding of the early universe and suggests that current theories may need to be revised. The discovery has sparked considerable debate within the scientific community, as these findings raise questions about the current cosmological inflation model and the Big Bang theory. While the Big Bang theory has long been accepted as the leading explanation for the origin of the universe, it has faced certain challenges, including inconsistencies with the laws of thermodynamics and a lack of clarity on what actually triggered the Big Bang. The James Webb Space Telescope is now uncovering galaxies that are almost as old as the Big Bang itself, raising doubts about our previous assumptions regarding the origins of the universe. Theoretical physicist Michio Kaku has weighed in on the matter, stating that the discovery of these ancient galaxies calls into question much of what we thought we knew about the beginning of the universe. Before these discoveries, it was believed that galaxies in the early universe were less developed than our own Milky Way. But these new findings suggest that we might be missing key information about galaxy formation. One of the most surprising aspects of the James Webb Space Telescope's discoveries is that it has identified 6 massive galaxies that existed just 500 million years after the Big Bang, some of which are up to 10 times larger than the Milky Way. This raises a profound question. If it takes millions of years to form a galaxy like the Milky Way, how is it possible that such large galaxies could have formed so early in the universe's history? Kotaku explained that this discovery may require a major revision of current textbooks on the origins of the universe. The James Webb Space Telescope's findings challenge the established timeline of galaxy formation and leave scientists rethinking what they previously believed about the early stages of the universe. These new observations reveal that many mysteries still surround the formation and evolution of galaxies. Despite the challenges of these findings to current theories, NASA remains committed to finding information about the origin of the universe. In a recent tweet, NASA revealed the discovery of a galaxy cluster that existed only 650 million years after the Big Bang. It is predicted that this herd will develop into a giant pale herd, Abel 1656. What is most interesting about this discovery is that it reveals a unique period of galaxy evolution, when galaxies form and merge rapidly. Thanks to the James Webb Space Telescope, astronomers were able to measure the velocities of 7 galaxies in the cluster, confirming that they are gravitationally bound and combined into a larger structure. Simply put, NASA compares these distant galaxies to drops of water in different streams that join one big river. This image shows how galaxies merge into larger structures over billions of years. These discoveries revolutionize our understanding of the early universe and challenge long-held assumptions about the nature and evolution of galaxies. The fact that these discoveries are forcing us to rethink the Big Bang theory suggests that we are on the brink of even greater revelations. The Big Bang may have happened, but the forces that started it are still a mystery. As the James Webb Space Telescope collects more information, we may be closer to solving these mysteries. What do you think of these amazing findings? Are they challenging what you thought you knew about the world? Leave your thoughts in the comments, and we'll continue to explore these exciting developments in future videos. Stay tuned for more as we embark on this exciting journey of world exploration.